All right, so let's go ahead and take a look at this objective. So we're going to go ahead and we're going to factor. And remember, we can do the x or not. What you're looking at are numbers when you multiply 12 and 13 together. So again, I don't want you guys using a calculator. So we would do this, by a long way. And I'm looking at 156. So it's negative 156, and I'm adding to give me a positive 1. So you're going to sit there and you're going to have to do different combinations of, multiplying things out. The thing about it is that, you're going to have to find a lot of factors here. So I'm going to go ahead and I'm just going to do something here. 2 and 6, 3 and 4, and you guys might be able to, instead of finding all these factors of 156, you might be able to just try some things out, right? Because when you factor this, you know that one of them has to be 13 and the other one has to be 1. So you already know what those factors have to be on the outside, on the right side of your parentheses. Now the question is what's on the other side? And 12 and 13, right? So it's you don't have to go through all these different possibilities. I'm 13 minus 12 is 1. So if I had a positive 13 here and I have a negative 12 here, then that would give me a positive 1t. So, you could find the factors of 156, but in the end, what you're trying to do, is you're just trying to, find this combination of getting 1. And I know 13 minus 12 is 1. So instead of going through and finding factors of 156, I would have just try to guess and check for that one. And then here we're going to factor out the smallest exponent. So it's either the most negative or the smallest. So what I'm factoring out is 3y minus 13 to the 1/5 power. And so I have 3y minus 13 to the 1/5. What I'm left with here is a 9y. And what I'm left here on this side is I'm going to subtract my exponents here. So I have a minus 2, 3y minus 13 to the 6/5 minus 1/5 power. So then I have 3y minus 13 to the 1/5. I have 9y minus 2 times 3y minus 13 to the 5 over 5, which is just 1. And then I'm going to go ahead, I'm going to distribute 3y minus 13 to the 1/5. 9y minus 6y plus 26. Not minus 26, plus 26. So 3y minus 13 to the 1/5 power, and I have a 3y plus 26. Okay. And then we're going to solve some logarithms. So remember, the base of the logarithm is 3, so it's 3 to the 2nd power is equal to x. So x is equal to 9. We're going to simplify this logarithm. Base of log is 10 when you don't have the base there. You're going to bring down the 8. So 8 log base 10 of 100. When you look at log base 10 of 100 is equal to x. So 10 to the x has to be equal to 100. It's 10 squared, so x is equal to 2. So this logarithm here is equal to 2 So it's 8 times 2, which is 16. Okay. Base of ln is e, so e to the ln of something is just the something. So this is all equal to 1.06. So basically like the e and then the exponent of ln, they cancel each other out. All right, and then we have this here. So ln e of this, so that I can bring down this exponent. So it's negative 0.225 ln of e minus 3. The ln of e is equal to 1. So then I have negative 0.225 minus 3. So I have a negative 3.225. Here I want to, it should say expand. That 13 should say expand. 14 should say expand. 15 should say condense. Okay. So this square root means that I have this coming in front. And then it's 3, actually maybe I should do this in separate steps. Okay. 1/2 log x cubed y to the negative 4th. So then I have 1/2 log of x cubed plus log of y to the negative 4th. And then I have 1/2 3 log x minus 4 log y. Okay. This should say condense. 16 should also say condense. So I'm going to bring my 2 up. I'm going to bring my 3 up. So then this is the log of x squared plus the log of x plus 1 cubed. Addition means multiplication. So this is log of x squared, x plus 1 cubed. Okay. We're going to solve these. Let's see. So I would take the log of both sides to get rid of the exponent in the top. So I'm going to go ahead, I'm going to bring down the 2x plus 1. And then I'm going to have the log of 3. I'm going to bring down the x minus 2. And I'm going to have the log of 7. So I have 2x log of 3 plus the log of 3 if I distribute. And then x log of 7 minus 2 log of 7. So I have 2x log of 3 minus x log of 7 is equal to negative 2 log of 7 minus the log of 3. If I move all my x terms to one side, then I can factor. So I factor out x, and I'm left with 2 log of 3 minus the log of 7 is equal to, hold on. This should be a 3. Is equal to negative 2 log of 7 minus the log of 3. So then I have x is equal to negative 2 log of 7 minus the log of 3 divided by 2 log of 3 minus the log of 7. Okay. 19, I'm going to just take a quick look here to see where we're at. We have a lot of problems here to go through. Okay, so 19. I'm going to condense this together to solve for x. So I have the ln of 7 times 2 minus 4x squared is equal to the ln of 14. When I have ln on the both sides, then I can set the insides equal to each other. So 7 times 2 minus 4x squared is equal to 14. So I have 14 minus 28. Distribute the 7. 28x squared is equal to 14. Subtract 14 by both sides, so I get negative 28x squared is equal to 0. So then x squared is 0, so then x is equal to 0. And then all I need to do is make sure that when I plug in x equals 0 in here that I don't get a negative result. If I get a negative result, then this would have been an extraneous solution and there would have been no solution. Okay. Here we're going to do some trig, so 10 squared plus 8 squared is equal to c squared, so 100 plus 64 is equal to c squared, so 164 is equal to c squared. Pull out a 4, so then that's 4 and 41. So then 2 root 41 is equal to c, because I square root both sides. Okay, so sine of a, here's a down here, would have been 10 over 2 root 41. I'm okay with you not rationalizing in the denominator. Cosine of c is 8 over 2 root 41. I do want to reduce those, so this is 5 over root 41, 4 over root 41. Tangent is 10 over 8, which is 5 over 4. Cosecant is 2 root 41 over 10, which is root 41 over 5. And then secant is 2 root 41 over 8, which is root 41 over 4. And then cotangent is 8 over 10, which is the same thing as 4 over 5. If I have t here, sine of t is 3 over 8. And I want to find cosine. So 3 squared plus b squared is equal to 8 squared. So 9 plus b squared is equal to 64. 4. Subtract 9 from both sides. So then I get b squared is equal to, b is equal to 55. And then b is equal to square root of 55. I actually thought my children were awake. Okay, so then cosine would have been root 55 over 8. Oops. Okay. Simplify here. So I do need to have my special triangle of 30, 60, 90. Root 3, 1, and 2. So then pi over 3. So 5 pi over 3 is in quadrant 4. 6 pi over 3 is 2 pi. So 11 minus 6 is 5. So 5 pi over 3, this is going to put me in quadrant 4. So this is the same thing as the sine of 5 pi over 3. Negative 5 pi over 6 is going to put me in quadrant 3. So this will be in quadrant 3. So this is the same thing as cosine of 7 pi over 6. Okay, so 5 pi over 3. The 3 in the denominator here means that I'm 60 degrees. So then the sine of 60 degrees is root 3 over 2. Because I'm in quadrant 4 here, that's going to be a negative. 7 pi over 6 is also going to, for cosine, is going to put me in negative. But now I'm going to be 30 degrees. And that is also a root 3 over 2. So then I get root 9 over 4, which is 3/4. All right. 9 pi over 4, so 7 pi over 4, negative 7 pi over 4 would have put me in a quadrant 1 here. That would have been a negative 7 pi over 4. negative 9 pi over 4 would have put me in quadrant 4. So this is going to be the same thing as negative sine of pi over 4. I'm just going to reduce it instead of changing it to a different positive angle. And then the cosine of negative pi over 6 puts me in quadrant 4 here. So then that's the same thing as a positive cosine of pi over 6. I do need my triangle again, 30, 60, 90, root 3, 1, and 2. I also need my 45, 45, 90, but we know that that's just root 2 over 2 for sine. So cosine of pi over 6, that would be 30 degrees. So then that is root 3 over 2. So then overall I get negative root 6 over 4. I want sine inverse. So the inverse function for sine goes between quadrants 1 and quadrants 4. It's a negative angle if you're in quadrant 4. So this is negative here. So then that means I'm going to be in quadrant 4. My 30, 60, 90 again. That does not look like a 30, 60, 90. So then the sine gives me 1/2 if I'm at a 30-degree angle. So then this is equal to a negative pi over 6. Okay? Because my domain goes from negative pi over 2. To a positive pi over 2. Cosine is valid in quadrants 1 and 2, cosine inverse. So if I'm negative, I'm actually in quadrant 2. This is the same thing as pi over 4. Pi over 4 in quadrant 2, so I'm going from 0 to pi for my domain, is going to give me a 3 pi over 4. So this will be the same thing as 3 pi over 4. Do more of these. 30, 60, 90. Root 3, 1, and 2. Tangent is valid in those two quadrants. So I'm going to be in quadrant 4. A negative, so I'm a root 3. 1 over root 3, which will be a 30-degree angle. So this will be a negative pi over 6. Here I'm looking at addition and subtraction identities. So pi over 12 is the same thing as 4 pi over 12 minus 3 pi over 12. Now 4 pi over 12 is the same thing as pi over 3. And 3 pi over 12 is the same thing as pi over 4. So really this cosine of pi over 12 becomes the cosine of pi over 3 minus pi over 4. And so there's an addition-subtraction identity. The subtraction identity is cosine, and then plus sine of them. So I will need a 30, 60, 90 triangle again, root 3, 1, and 2. So cosine of pi over 3 is 1/2, root 2 over 2, plus the sine of pi over 3 is root 3 over 2, and root 2 over 2. So this is root 2 over 4 plus root 6 over 4. So this is the same thing as root 2 plus root 6, all divided by 4. 11 pi over 12. Oh man, I found it for cosine. What I was going to say is that I could have used, if I had found it for sine, right? So if I had found sine of pi over 12, I could have done 12 pi over 12 minus pi over 12. So I could have used, something that I already had if I wanted to, which maybe I do. In the end, it might be easier, when you're looking at these fractions, it might be easier instead of you thinking about certain things that, you're like, oh, I could just do this. and then get it. So maybe I'll do that, because pi over 12 we just kind of did for cosine. So we would have known that the sine of pi over 12 is the same thing as the sine of pi over 3 minus pi over 4. So I could, and sine's identity is sine cosine and it's minus, so then it's cosine sine. Okay, so I could have done this. I could have used my triangle. So let's see, 30, 60, so 60 degrees. So sine is root 3 over 2. Cosine is root 2 over 2. Cosine is 1/2, and sine is root 2 over 2. So this would have given me root 6 minus root 2, all divided by 4. What makes this nice is that I could have done, so this would have been sine of pi minus pi over 12. So this would have been the sine of pi cosine of pi over 12, which I have already. And then plus, nope, minus, just kidding. Cosine of pi sine of pi over 12. Okay. We know what the sine of pi over 12 is. It's here. Cosine of pi is equal to -1. And then sine of pi, though, is 0. So this entire term cancels out here. So I'm just left with a -1 and a root 6 minus root 2 all over 4. 2 negatives make a positive, so then I would have just been left with root 6 minus root 2 all divided by 4. Okay? All right. Keep going through. So if I label this x here, cosine would have been 2 over, 3. Label this b, so then 4 plus b squared is equal to 9, so b squared is equal to 5, so b is root 5, root 5. Cosine of 2x is the same thing as 2 sine x cosine x. So then this is 2 times sine, which is root 5 over 3, and then cosine, which is 2 over 3. So then this would have given me 4 root 5 over 9. Cosine of 2x, lots of different ways I could do it. I always memorize it as the cosine squared minus sine squared. So then I would have had cosine of x, the quantity squared, minus sine of x, the quantity squared. So then cosine of x is 2/3 squared minus root 5 over 3 squared. So then I would have had 4 over 9, and I would have had minus 5 over 9, so I would have gotten a -1/9. Tangent is equal to -8. So this is -8 over 1, so that's x. That makes this 8 over 1, so then 1 squared plus 8 squared is equal to c squared. So 1 plus 64 is equal to c squared. So 65 is equal to c root 65. So then 2 sine x cosine x. So then 2 times sine. So sine would have been 8 over root 65. Cosine would have been 1 over root 65. So then I would have gotten 16 over 65. Same thing. Cosine x squared minus sine x squared. So cosine would have been root 65 squared minus 8 over root 65 squared, which would have given me 1 over 65 minus 64 over 65, which would have been a -63 over 65. And we're going to keep going here. Wow. This is going to be terrible for me to grade. Not only is it terrible for you guys to do, but it's going to be terrible for me to grade. All right, it's okay. So sine of theta is equal to root 3 over 2. So my triangle, 30, 60, 90, root 3, 1, and 2. So now what I'm looking at here is sine of theta being root 3 over 2 makes a 60-degree angle. So theta is equal to pi over 3. It is a positive angle, so I want this to be in quadrant 1 and quadrant 2. So theta in quadrant 1 is pi over 3. Theta in quadrant 2 is 2 pi over 3. Cotangent of x is equal to -1. So that's going to put me in either quadrant 2 or quadrant 4. This is your 45, 45, 90 triangle. So then I want pi over 4 in both of those quadrants. So x is 3 pi over 4 or 7 pi over 4. Okay. Tangent to the fifth of x minus tangent of x is equal to 0. So tangent of x, tangent to the fourth of x minus 1 is equal to 0. So I get tangent of x equal to 0, which is 0 and not 90 degrees because it's undefined, 180 degrees, so that's at pi. And then tangent of x to the fourth, so then I get tangent of x to the fourth is equal to 1. Take the fourth root of both sides, so I get tangent of x is equal to plus or minus 1. So that means I'm going all the way around with pi over 4. So then that gives me x is equal to, what's this x is equal to? Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. 47, so then cosine of 2 theta is equal to negative root 3 over 2. So my 30, 60, 90 again, root 3, 1, and 2. So then I want cosine, so that'll be a 30-degree angle. So I have pi over 6. I'm doing 2 theta, so I need double the angles. So pi over 6, nope. It's in quadrants 2 and 4. So then that's 5 pi over 6. Oh, not quadrant 4, quadrant 3. 7 pi over 6. And then I have to add 2 pi. So 5 pi over 6 plus 12 pi over 6 gives me 17 pi over 6. So I have a 17 pi over 6. And then 7 pi over 6 plus 12 pi over 6 is 19 pi over 6. Divide everybody by 2. So theta is 5 pi over 12, 7 pi over 12, 17 pi over 12, and 19 pi over 12. 49, we're going to factor. So I have sine of x, sine of x. I want a positive 2 and a minus 1. When I take sine of x plus 2 equals 0, and I solve this, I'm going to get sine of x is equal to negative 2, which does not work because sine only goes between positive and negative 1. So then I have sine of x minus 1 is equal to 0. So sine of x is equal to 1. Sine is equal to 1 at pi over 2. 51. Oh, this might be the last one. Okay. Oh, man. Sine squared minus cosine squared. Okay. So I'm going to use my identity to change cosine squared into 1 minus sine squared. So I have sine squared x minus 1 plus sine squared x minus 1 is equal to 0. So 2 sine squared x minus 2 is equal to 0. Factor out a 2, so that's sine squared of x minus 1 equals 0. So sine squared of x minus 1 is equal to 0 when I divide both sides by 2. So then I get sine squared x is equal to 1, square root both sides, so I get sine is equal to plus or minus 1. So x is pi over 2 and 3 pi over 2. All right, and that is it for all the odd number questions, I think. Yeah, we're done. Look, we're done. All right, that's it for this one.